Okay, task two. And again, like we a lot of these we see in the kit, in the exam kit, which is why it's so important to work through the kit. So first of all, say closing inventory should be 30%. Oops, sorry. Let me just get that, erase that. Should be 30% of the following week's sales volume. And if you've been doing the kit, you will know that what they're really telling you here is to look ahead and take 30% of this will be the closing inventory here. But this closing inventory becomes opening inventory here. So we simply take, yeah, why not? Let's just do it. 30% here of this 69,000 is equal to 20,700. So what we have here is closing inventory of 20,700. But of course, that is the opening inventory, of course, of that here. And then I do exactly the same thing. 30% of the 67,000, of course, here is the closing inventory here, which is 20,100. And that is, of course, the opening inventory here, of course. And then 20% of the 70,000, of course, here is 21,000. And of course, that becomes the opening inventory here. And then, of course, 30% of the 72,000, of course, here is 21,600. So what we have done for ourselves is to find, if you like, first of all, the closing inventory. Right, and the question does say to us, it tells us that 8% of all production will fail quality control checks. So what we actually produce will be more than the good production, because we need to account for these 8%. But let's just first of all look at what the absolute or the perfect, if you like, production would be, what we really need to produce in order to get these volumes in terms of the perfect production without any errors, and then we'll adjust for the errors. And so here the argument is you need to push out 68,000. You already have well, two things. You need to push out 68,000, so you definitely have to produce those, and then you also have to produce this extra here, of course, what's closing, because you need to keep those, but you have 20,000 already at play, so you have 68,000 plus 20,700 minus 20,000 because these already exist. So sales volume plus closing inventory minus opening inventory will give you your production. So 68,000 plus 20,700 minus 20,000 gives you 68,700. So you have 68,700. So just apply the same principle. 69 plus 20,100 minus 20,700, and just keep going right across. And I'll just do that on my calculators really quickly. And you have here 68,400. You do the same thing here, you will have 67,900. You do the same thing here, you will have 70,600. That's what you're going to have. Now, the question then goes on to tell you that this is the good production. Well, it's letting me write here. This good production, it says that 8% fails quality control. So what's happened here is that you would have produced a certain number of products. 8% will fail. So 92%, you can think of it that way, is this good production here of 68,700. Same thing for this, of course, and this. So you're going to produce, or you can think of it like this, 8% of X are going to get bad. And then when they go bad, whatever you have left will be this 68,000. So if you started off with 100%, which is what you produced, you're going to lose 8%, and then 92% will be this good production. So in a way, I can find what that full production is by dividing in every scenario, everything across here, dividing all of these guys by 0.92, or doing what I have to do to get it to 100%, right? I mean, email me on the math of that, but the point is here, if 92% is equal to 68,700, the question is, what is 100%? The question. So I suppose the first question to find is, well, what is 1%? And dividing 68700 by 92, and then multiplying that by 100, because we want to know what 100% would be, right? So when you do that, and you chuck that in your calculator, you will see that your total production here is 74,674. Here it's 74,348. Here it's 73,805, and here it's 76,740. And of course, I can subtract the two or find 8% of this, whatever I do, and get my answers of the rejected productions of 5974, 5948, 5905, 614, 6140. Cool. Okay, the next question then goes on to ask us. It says that you have the following information. Let me just change my pen color just to make it look different. So you've got the following information. We want to produce 61,000 items. So we want to produce 61,000 items. And we know that each item requires 11 kilograms. So multiply that by 11 and you will have 68,700. So you need 68 sorry, let me just 61,000. Let me just do that my calculator again. 1 second. 61,000 times 11 is 671,000. Sorry, where's my eraser? I knew that was a bit off. So here we are. 61,000 times 11 kilograms is equal to 671,000. We need 671,000 kilograms. Now, we are told in a perfect scenario, that's what we would use for production, but we're told that 5% of this gets wasted. So this is needed to produce this. So we need to make sure we are putting more, if you like, into the furnace. The question is how much more? So because we know 5% of what we put in gets wasted, we know this is the equivalent of 95%, isn't it? So therefore, if I divide this by 0.95, I will, in terms of input, I will get the answer I need, if you like, divided by 0.95, and that gives me 700. That gives me 706,315.7, but I'll round that up. So those are the number of kilograms I actually need to just put into the furnace, if you like, to start this process. Right. Okay, then. So we know the question tells us, if you like, in the we have in the question an earlier sheet that we need to produce 7. Oops, that was all the time. That we need to produce that we need 706,316. And we are told in the question that we have an opening amount of, I just go back and check that. I have it somewhere. Let's just go back and check that. I have an opening amount. Yes, that opening inventory is 84, closing is 80. So let's just go back there. Opening is, opening inventory was 84. Opening inventory. Oops, sorry. Opening inventory 84. Closing inventory is 80,000. So the question here is how much am I going to purchase? So I have 84,000 to start off with. I'm going to have to purchase, if you like, a certain amount, and then I need to make sure I have 80,000 left because I'm going to be releasing 706,316. Or you can look at it by saying that, well, I'm going to need 706,000. I need to make sure I have 80,000 left, but I have 84 to start with. So I can do 706 plus 80,000 minus 84,000, which is this equation in effect. Because when I find X, I'm ultimately saying 706,316 plus 80,000. So what do I need for production plus what I need to make sure I have left over minus what I had at the beginning because that was already there, right? And when you do all of that, you should arrive at the answer of 702,31316. And that's what's going on for that one. Okay, let's look at labor. So I'll just change my pen color here a little. So labor here, we're arguing that 88,000 items will be made in July. and 25 items are made in 1 labor hour. So we, in effect, need to make 88,000 to satisfy that demand. Divide those two things, of course, and you will have a total of 3,520 hours. That's what you need in total. That's what you need in total. Now, what do you have available to you? You have 15 staff who work 180 hours. So what 15 times 180? We have here 15 times 180, and that's 2,700. So we have 2,700 hours, right? That's what we have, 2,700. So ultimately, what we have, if you like, is this need for overtime hours. And that's the difference, of course, between the 3,520 and the 2,700. So subtract 2,700 from 3,520 and you will have 820 hours. Okay, so let's look at machine utilization. Let's look at machine utilization. And what we have here is telling us that there are 90 machines in the department, and each machine can be used for 240 hours. So let's look at that. So that's 90 times 240 to find out what that total is. And what you see here is that you have a total of 21,600 hours machine time. And what you're making currently is 9,750 times 2, because that's the time it'll take for that. 9,750 times 2 gives you 19,500. So you have availability of 21,600. You're doing 19,500. So in terms of utilization, we're talking about 19,500 divided by 21,600 in terms of percentage utilization times 100% or whatever it is you're going, and you should get 90.2 something. So it tells you to round to the nearest whole percentage, which brings us to 90% to 90%. Okay, so we have some interesting information here about production capacity. And what we see here is a scenario where they're telling us, listen, you need 8 kilograms of material to make each of these units, but you currently have 6,000 kilograms of material. So the question is asking, with the material you have, how many units can you make? So since you have 6,000 kilograms, if you like, available, and you need 8 kilograms to make a unit, to 1 unit, the question here is how many can you make with 6,000 kilograms? So dividing 6,000 by 8 will bring you to 750 units. So with all the material you have available, you can make 750 units. Let's look at time. Without overtime, 45 minutes is 3/4 of an hour. So that's 0.75, 3/4 of an hour, 0.75 hours. Without overtime, sufficient direct labor. So labor here, we have 450 labor hours, and we are needing 0.75 to make 1 unit. So I'll just do that over here. Well, remember that this is recorded, so you can always see what I've done there again. So we have 404. Sorry. We have 450 hours available, and currently 0.75 hours will make 1 unit. So the question here is, how many units will 450 hours make? So we simply divide the 450 by the 0.75, and we can make 600 units with the current situation with labor. So then machine time is budgeted to manufacture. Again, here we're told 12 minutes will make, so 12 over 60, and that's, if you like, 1 over 5. So that's 20% of an hour, right? So that's 0.2 hours, if you like. And you currently have 140 available. So I have 140, but you have 0.2 will make 1 unit, and therefore 140 here divided by 0.2 will give you 700. So we have 700 units. So it's interesting because in a way you can think of this as limitation accounting. We can know what's limiting us here. if you like. And once we solve one problem, we then have the next problem to solve. So in a way, you could almost argue that first of all, we are restricted by time, normal labor time, and then we're restricted by machine time, and then we're restricted by material, if you like, if you're looking at a spectrum, if you like, if you think about it. So anyway, without overtime, the maximum sales volume, well, without overtime, with the time you have, the best you can do is labor time, 600 units. You can't do more than that. That's your peak, 600. With unlimited overtime, so we solve this bottleneck. Now we're restricted by machine time. So the best you can do is what the machine time can do for you is 700. And when you solve that bottleneck, you then are restricted by materials. So you can see that it's possible to have bottlenecks and bottlenecks depending on what the situation is. But this is the situation as it is. Cool, great stuff. That's the end of task 2.